what you're gonna owe, right? Um, you know what? You can just call this owing money. That's basically just call this owing money. Page 63, yes. And grab a highlighter. I'm just gonna introduce you to some of the concepts here. So I actually think that you need to know terminology as you go out into real life and you get into these things. Um, what's a collateral? It's just an asset is held in security, right? So when you go get a loan, the bank just won't hand you the money. They'll be like, "What do you own? You have a car? Is it paid off?" And it's like, "Okay, you have a car, so tell me about the car. What model? What year? All of these things." They'll know. They'll make a list of what you have. And if they give you a loan, they can come after you after your stuff if you don't pay it. That's a collateral. So they take it, they have that as a security against the loan. Okay. Mortgage, folks, mortgage is just a loan towards real estate. That's what a mortgage is. It's just a big amount you will owe, but it's real estate. It's safer for them. It's safer for the bank. Another thing here, a loan can involve a single payment or smaller regular payments. So most of our loans are going to just be like smaller deposits, maybe monthly, weekly, what have you. Okay. So this is another important concept. With each payment period, the interest charge decreases while the principal paid increases. Um, why is that? It occurs because each payment decreases the balance of the loan, so the interest on the remainder will be less on the next payment. I'm going to talk about this as we go through this. I'm going to touch on this again and again. Okay, but you're getting charged a little less interest as the months go by or weeks go by as you're starting to pay off because you owe a little less after every payment. Okay, is this blurry or is it just me? Are there any glasses? There you go. We're purchasing a car or a house. There's a down payment. Okay, down payment is usually must be paid. I'm just going to say that. So you will see a down payment quite often. Make sure you subtract the down payment from the present value. I would highlight that. Credit cards are technically loans, right? Credit cards are loans. The credit card gives you money that you must pay it back. Most credit cards charge a crazy interest rate of anywhere between 18 to 33%. The most common interest rate is 19.99 or 24.99, anywhere in there. If your credit is bad, your interest rate goes up. Okay. If you mess up on the payments, they go up. Okay. So don't spend it like it's free money because you're going to have to pay it. Savings accounts make the least amount of interest. Mortgages charge even more interest than savings, and credit cards charge the highest rate of interest. That's not too crucial. We'll figure it out as we go. When using the TPM solver, the number of payments and the number of compounding periods are often different. Pay attention. I don't think I need you to highlight that because I'm talking about that all the time. N is the total number of payments, not compounding periods. When investing, you want as much interest as possible. Is that fair to highlight? Right? If you're investing, the higher the interest rate, the better. The opposite when taking out a mortgage, you want to get the lowest possible interest rate. Okay. Um, interest charge on the loan will be decreased by any of these factors. I think this is very important. I'm going to circle all of these. Okay. Any of these will decrease the interest paid. right? So the interest rate decreases, you pay less interest. Compounding frequencies decrease, you pay less interest. Regular payments are made, you will pay less interest. Payment value is increased. So let's say you call the bank, it's like, hey, you know what? My payment is 150 a month. Make it 200 a month. Pay it off faster, right? So all of these will save you interest. Saves you interest. Oops. Can you see that? There you go. Um, Lease, a contract for purchasing the use of property from another, the lessor, for a specified period, right? For a specified period. And this is also worth highlighting. At the end of the lease, usually you have the option to purchase for the residual charge, the amount owing on the car. I think it's normally referred to as the buyout. When you lease a car, you're basically renting it for like a specified period of time. And at the end of the lease, you can always purchase it if you wish to do so. Here's another important concept. I'm going to use a different color for this one. Equity, it's the difference between the value of an item and the amount still owing. I'm going to leave it like that for now. That's equity. Equity can make buying a house a form of investment. Okay. Renting has no equity. Let's highlight that with a different color. When you rent, you do not build equity because you're not owning that property. Appreciation. This is another one. Appreciation. When the value of an asset increases over time. Depreciation. When the value of the asset decreases over time. So normally real estate is considered an increasing asset, appreciating asset, whereas cars or most other items you buy, they lose their value over time. I'm going to come back to this later on. Okay. So lots of terminology. I'm not going to expect you to know all of this after today, but that way when I throw it at you in a question, you're not like, what? What's at the collateral? What is that? So be prepared for that. Let's keep going. 64. These are somewhat scary formulas right now. I'm not going to use all of them, and we're not going to need them all today. Okay, and this is the reason why I'm giving you them all. Okay, so don't be overwhelmed. Just be like, these are tools that I'm giving you, and if you at any point see like, oh, wait a minute, this formula, like Mr. Dirksen solved this question this way. I wonder if I can use this to do the same thing. You will most likely be able to do that. So I'm going to kind of just try to simplify it and do it consistently one way. And if you figure out that one of these helps you do that, the same thing, and you like it more, you go for it. Okay. Important formulas that you need. Let me see. I'm not going to highlight any yet. Maybe after a lesson or two, I will come back. It's like, okay, these ones are important. Okay. But we know that this one, sorry, I'm going to highlight this one for sure because I'm using that a lot. Balance and the amount of loan still owing after n number of payments. That one is very important. Okay, I will say this. N is equal to years times py. That is still always going to be true. When is a capital N, Mr. Dirksen? When is a capital N? Capital N is if you want the balance at the end of the loan, like at the very end of the loan, which is always going to be most likely 0. Okay, you want the cost to be zero. This is also important here. Um, Interest on a loan. Here it is. I'm going to highlight this one. Interest on a loan is the payment times n. This is all of the payments you've made in total minus the present value. Okay? Or write this down. You can use sum of interest as well. And you go start, end. So I'm going to highlight that. The or is very important because I use this quite often, the sum of interest and balance. These two are the ones that I highlighted. I'm using those most often. I will talk about equity a little later. Okay, let's do an example and then I'll expand on these as we go by. Okay, over here, example one. I will put a little note here, no payments, no regular payments. I will do one of these because at least you've seen it, but very rare that you do this. Okay, so actually, if it's a student loan, you might not make payments until you're ready to do so. They give you a bit of a grace period. So Trina's employer loaned her $10,000. So loan $10,000 at a rate of 6% compounded annually to pay for textbooks and tuition. The loan is to be repaid in a single payment. The loan is to be repaid in a single payment at the end of the 5 years. How much will Trina need to pay her employer at maturity on the maturity date? Well, can I use simple interest formula here? Nope. Why not? It's compounded interest. Right? Simple interest doesn't work here. I'm just saying, like, if you ever look at your study sheet and it's like, oh, maybe simple interest. Like, nope. And if it's compounded, you can use a TVM solver every single time. It works every single time. So here we go. It says compounded annually. So that means once a year. There are no payments, no regular payments being made, just one single payment. Okay. So PY is equal to CY. And so here's where it's going to be a little different. Okay. No payments. Present value is negative 10,000. Actually, nope, it's not negative. Where's that money coming? If someone gives you $10,000 loan, the money is coming to you, correct? So that's how this is different than investing. It's coming to you. And interest rate is 6%. This is going to be 5 years times whatever PY is. So it's just 5. That's all I'm going to do here. But what's left to be solved here? Well, future value, which is that one payment you're going to have to make at the end. So let's go ahead and solve this. Very simple example here. 10,000, the sign is very important. I'm going to go 1 and 1. Oops. 1 and 1. Future value is what we're solving for. And so that's negative 13,382.26. Trina will have to make a single payment of 13,382.26. I'm going to highlight the no regular payments part, or at least circle it. Okay. So payment is 0. Rare, but it could be. So that's A. For B, how much did the loan cost her? What does that mean? What is it asking for? It says up there in all the formulas I gave you, yes, which is called, starts with an I. Interest. Yes, yes. Asking for interest. Asking for interest paid. Okay. Is N a whole number? Yes, I can use this one. Interest, sum of interest needs a start, which is, it's, if you want from the beginning, it's 1. And I'm going to go to 5 because it is the very end of the term, which is 5. So let's use that one. And then we use the formula just to verify and make sure we got this. So you remember how to do this? You quit, not the course, just the application. And then you go interest 1 to 5. So there it is. You don't have to have the negative in here. That's more just for you to understand. And you can tell, right, from 10,000 to this, you paid 3,382 in interest. You can tell fairly quickly here that that's what it is. Or look at that formula I gave you there. Interest is PMT times N minus present value. So what are my payments? 0, right? There are no payments? It's just a, sorry, what happened there? This one doesn't work in this case, does it? Because it would be 0 minus present value, which is 10. It'd just be 10,000. That's not correct. Yeah, go ahead. So if there are no payments, this one doesn't work. It would just be, yeah. Yes. So you're looking back at the investing part, right? When we did the investment, you did the FE minus PV, right? Yeah. Because this is a loan, this works when there are payments, but when there are no payments, then I would have to use that one, FV minus N times, right? There were also payments on there. I gave you a longer one with payments as well, right? Which just turns to 0. Okay. I'm just gonna park it there for now. I don't wanna confuse the living daylights out of you. But I think, is this the one you're thinking of? Future value minus PV minus N times PMT, correct? Yeah, that still works. So it'd be 13,382.26. This is now gone. There are no payments. Minus present value. Okay. Okay. We got it. So we gotta then make adjustments to our formulas there. Can you for now just go with this, and I want to go through the booklet, and then we'll make changes to the formulas up there tomorrow, okay? Because if I make the change on the fly right now, then I need to make sure I tell you exactly why I changed it, okay? But this is the total interest nonetheless. Okay. All right. What else is it asking? What would you expect to happen to the cost of the loan if the interest was compounded monthly? Let's answer that. I hope you still have some room. Try to find room. If the compounding periods increase, so will the interest charged. Okay. The more off. Okay. When it comes to investing, just hear me out here. If you want to invest, the higher the compounding periods, the better. Okay, because more interest is compounded, it's calculated more frequently. If you're paying interest, you don't want the high compounding period because then you're going to pay more interest. You don't want to be on that side. Okay, so investing, higher compounding periods is good. When you're borrowing, higher compounding periods is bad. How would that change? Let's look at annual is once a year. If this had gone to monthly, this would have been 12. So, right, it's not good. A higher compounding period is not good for you. Okay, let's go over to an example with payments. Go to 65 here. 5. There we go. Okay, so Lars borrowed 12,000. We know it's a loan situation, right? He borrowed 12,000 at 5% compounded monthly to buy a new jet ski. Lars negotiated regular loan payments. Their regular loan payments are 350 at the end of each month, right? So each month until the loan is paid off. How long will it take for Lars to pay off the loan? Well, let's first figure out. Okay. All right. It says compounded monthly, correct? So we're going to start with 12 here. There are regular payments. So you got to go check out how often are they happening. They're also monthly, correct? So this happens to be 12 and 12, but not always. Credit cards, for example, they're compounded daily, most of them, but you make monthly payments to pay it off. Okay, so this would be 365. This would be 12, right? PY would be 12. So careful. You want to pay it off. So future value for most loans is 0. Payment, you're going to make $350 payments and they're going to leave you. So it's 350 negative. What's present value going to be? 12,000. Is it positive or negative? It's positive because you're getting that money to go purchase your jet ski, but the money came to you to make that purchase. I'm going to put a positive in there just to make sure you understand that. 5%, that's a sweet interest rate, by the way. And then N is what we're going to find out. Okay, that's the only unknown, and that's where time is located. It's embedded within N. So go ahead and follow me here. I'm going to put a 0 there for now. This is 5, 12,000, negative 350. So please always think about where's the money going. Okay, always think about that to not get the issue with TVM solver not being able to solve it or you getting the wrong answer. Alpha enter 3707. I'm going to write down all decimals because I can't just copy paste this. Okay. There it is. It doesn't ask us how long in years or months or anything like that. So how about we're just going to make sure we understand. Time would be 37.07 what? What does this represent in this case? Whatever this is. So be this many months actually. Or You could do years is 370732. Oh 0732. I'm gonna round to 4 decimals divided by whatever PY is. That's 3.09 years. We're not specified what else needs to happen, so we're just gonna leave it at that. So this is A. We've answered that. B, what would the balance owing on the loan be after 1 year? You can do this. Balance owing, you need to go 1 year times whatever PY is. PY is 12. So you're basically asking, what's the balance after 12 periods have gone by? And we'll figure it out, right? So that's how if you just go balance 1, you're going to figure out how much you owe after 1 month in this case. So I'm going to go apps, finance. So balance after 12, and this is all based on what's on the TVM solver. So it's this much that is going to be owed at that point. 8316.34. We know that balance at the end of this thing is 0, but what about in between? You got to use balance, okay? You got to use this function, balance, okay? C, what would be the balance owing on the final payment? Is this fair to ask at this point? I think you should be able to handle this. Balance. And this is what I mean here. Most loans, you don't pay the same amount right until the end. The last payment is usually a little less. The very last payment is less than a full payment. Because you're making 37 payments of 350. And what about this little chunk here? Right? There's going to be something left on the last payment. So what you do is, how many payments will you make in total in this case? You're making 37 whole payments. So let's go and find out how much is left after you make your 37 payments. Copy paste. Not a very common question, but this is, I thought real life is pretty important here. 2556 is going to be your last payment. Because after 37 whole payments, you still owe them this. Okay? 37 payments of 350 bucks, right? Last payment is going to be 2556. Actually, if you sign your contract, it will tell you what your last payment is. Like they actually say this many payments of this much, and then the last payment will be a little less to just make sure the balance is 0. Okay. D, what was the total cost of the loan? I'm glad you asked. I'm going to go, can I use sum of interest here? It's a good one. I cannot use sum of interest because n is a decimal. Okay, so you have to use the formula. I'm going to give myself a bit more space here. D, I'm going to go interest is going to be, and this is where the problem arises with the formula I gave you. You're going to get a negative at first. Sorry guys, I'm having a moment here. I don't want to throw you off, but don't copy this for now. If I were to go with this one that I gave you, this is the one I gave you, right, for investing. So future value is 0, present value is 12,000 minus you're making 37.0732 payments of $350. And so the sign is the problem here. That's what the problem is in this case. So I'm just going to say this. Hear me out here, please. For loans, this is what we're going to do. I know some of you are going to figure it out just like that, but this is interest for loans. We're going to go present value minus n times PMT. Okay? So present value is 12,000 minus 370732 times 350. And that is going to be 12,000 minus, if you multiply these two here, you get 12,975.62, which is, I know it's a negative, but it's this what we're after here, 97562. There. That's how much interest was paid. So it's the difference between what you got for a loan and how much you paid back. Okay? And I'm going to have to come back tomorrow and fix that to make sure we have our story straight here. And this is the only reason we couldn't use sum of interest is because n was a decimal. We had to actually solve for it. Okay. All right. I'm going to stop here, but I would like you to try. I'm going to go 65 and 66 as well as 67 because there's a credit card question there. Yes. And then we're going to do leasing tomorrow. So page 65 to 67, please. I will post the keys to that. Make sure you get started on this one now so you're not stuck later on and you can ask me questions. 8 minutes.